Hey, welcome back. It's good to see you again. Thanks for joining. Today on the bench I got the HP 8640B signal generator again. I wanted to get this part of the video filmed and off my bench because I got other things I need to do. I filmed the other previous two segments about 2 months ago, and then I put this aside, and I've been focusing on other things, but I want to get back to this and finish it off so it's complete. So what I want to do today is I want to have a close look at the metering in this and the output attenuation, and to kind of compare and see what's going on here. I want to see and verify if this is working or if it's not working. The meter has triple function. It does AM modulation level, it does FM deviation, and it does output level in volts or dBMs. Now, when I was doing the previous two parts of this video, I noticed that there's some irregularities going on with the metering. It didn't seem to work properly, and it didn't seem to make sense with the output. But since I've been playing with it this morning, it seems to be behaving, and I have a feeling it's because of these switches. I have these, after a bit of use, these switches are starting to wake up and starting to behave. So I think that was probably my initial problem when I first started using this, and I found that the output wasn't matching anything that was meaningful. So today I want to try going through some of the tests just to measure the output levels and see if it matches the metering and what's going on with that. I did go through and read, section 13 of the service manual, and it gives you a breakdown of what's supposed to happen here, and it gives you a write-up of how the circuit works and what components are responsible for what purpose in the circuit, and it goes through and tells you all that information, and then it has a little bit of troubleshooting section here if there's a problem. I don't think we need to get into this too deep because I know this is working. The scale annunciator is working. Meter drive is working. Positive peak detection, I'm not sure. I just wanted to go through, and what my plan is, I don't have the proper equipment to do a full calibration on this. What I want to do is just connect up some equipment and measure the output and see if it coincides with what the meter's telling me. For a signal generator doing just AM FM tuners, this is not as critical as one would think. The outputs, yeah, we can get by with just a rough estimation of what the output is. It doesn't have to be super accurate, but more accuracy is better. So let's turn this on. And I had this thing running for about an hour before, and it's all warmed up now. Okay, so I got the signal generator warmed up. I got my scope on. You should be able to see your scope in the corner of the screen. Now, what I want to do is just measure the output on my scope and see if it coincides with what the meter's saying. I have a feeling it might be off a bit. So what I'm going to do is I have a BNC connection, and I'm just going to pop this on the output, and I'm going to terminate it with one of these. This just has I can't open it now. It's got a 50 ohm resistor inside, terminating the BNC connector. I'll plug that on, and then I'll connect up my scope through a BNC line, and that's it. We got it set to 16.25 megahertz. Sorry, 1.625 megahertz. Let's lock that on. And I am on a 1 millivolt scale, full scale. So as soon as I turn this on, we should be getting 100 microvolts. Because the meter comes up, and on my scale, let's see here, if I set this going down as far as I can. I can't even get, it's more like 0.11. So let's turn this up to 500 millivolts, microvolts, sorry. 500 microvolts, yes. And our scope is reading 1.7 approximately millivolts. Now that's a peak. Let's see, V max. Let's try and get this set straight. Measure voltage. V max. Let's go with our RMS. I think that's better for this scope. Okay, so RMS, we're reading, this I believe is peak, and my scope is going to be reading RMS, which is 700 microvolts, sorry, 700 microvolts, jumping around. So let's turn this up to 1 millivolt. We'll see what our scope says. Scope comes back at 1.9 millivolts. Okay, let's go up a scale. Let's go to the 10 millivolt range, and let's take it up to 5 millivolts. This is 30. Okay. So we have 5 millivolts here. We got 5.51 millivolts RMS on our scope. Let's go up to 10 millivolts. And that brings us in at 10.9 millivolts RMS. Maybe this meter is in RMS. I didn't think it would be. $100 millivolt scale, let's turn it up to 50. Millivolts there. And we got 55.5 millivolts RMS on the scope, which is pretty close. Let's try turning this up to 100 millivolts. I'm having a hard time with my metric today. So we're at 100 millivolts here. Meter shows 110, so we're about 10% out. Let's go up to 1 volt scale, and let's turn this to 500 millivolts. And the scope is showing 571 millivolts. Turn it up. That is 1 volt. And we are showing 1.17 volts RMS. So it's doing not too bad. Let's turn this up until we get clipping. I'm at 3 volt scale, or 3 volt scale, so I'm at 1.5 volts now. Turn it up until I see clipping. Right there. Right there. And I'm at about 2.3 volts on this scale. 2.59 on the scope. If I go beyond that, it's warning me to reduce peak power. putting a strain on the power amplifier or the output amplifier. So it seems to be okay. Let's try it on my spectrum analyzer. Okay, I hope you can see that good. I don't want to turn the brightness too much because then it starts to bloom and we lose focus. So I'm going to keep it right about there. So I'm feeding itself its own calibration signal, and this is what this says here is a 299.9 megahertz at minus 20 dBms. And if I go peak search, hit that peak, the marker's at 304 megahertz, showing a minus 21.4 dB signal. And I've had this warmed up here for maybe 10 or 15 minutes. It's probably not fully warmed up. And that diamond there, that's our marker. So let's disconnect this and connect up our signal generator. One thing I want to do is remove the 50 ohm termination I have on the T. And I'm going to remove the T as well because we don't need it any longer. Because the spectrum analyzer already has a 50 ohm termination inside. So let's connect up our signal generator. And let's see here. I got the signal turned way down. Let's start with 100 megahertz. Just give me a second here and I'll tune it into 100 megahertz. There, locked in at 100. Now let's turn up the amplitude. You should see a spike coming up. There's our signal. Let's see here. Let's search for the peaks. Next peak left. There we go. So our marker shows it at 105 megahertz, which I believe my spectrum analyzer probably needs alignment. And it's showing minus 55 point, well, it's jumping around quite a bit. Let's just say minus 55 dBms. And on the signal generator, I'm at the minus 60 scale. And let's see here. This should be about minus, I got it cranked right up, minus 57 dBms. And this is reading minus 55. Which is pretty close. Okay, let's try something else here. Let's turn this down. Let's go up to minus 40 dBm. This should be minus 40 right there. And what does it read? Minus 40 point change. It's pretty good. So it is working. Let's restart that. Okay. And we're coming up at 206 megahertz at minus 40 dBs. It looks like the signal is jumping up and down. But on the scope it was rock stable. I think my spectrum analyzer has problems. Not quite sure. This probably needs a good tune-up. Let's switch this frequency around. Let's go up to 250. $250 locked in. Peak search. 255. And a minus 40 dB signal. Let's try different amplitudes. Let's go up to minus 20. Turning it up to minus 20. Right there. And we're reading 20 points, minus 20.6 dBs. So we're good. I think it's okay. I think we're okay. I'm pretty pleased with this. Yeah, doing alignments on AM/FM radios, you don't need supercritical output level adjustment. You just need to know the ballpark figures. So this is going to work, and it seems like everything is bang on, except my spectrum analyzer isn't showing the right frequency for some reason. Let's set, let's go back to 100 megahertz. Center frequency, 100 megahertz. Okay. There we go, 100 megahertz. Span. Let's go from 90 megahertz. Span. 20 megahertz. Peak search. Showing 98.5 megahertz at a minus 20.5 dB signal. I haven't changed the signal at all. Signal strength, still good. Let's try some modulation. Try some FM modulation. You can see how that waveform is moving. I've got a 1000 hertz tone modulator. Let's turn it to 400 hertz. See it twitching around there. 1000 back to 1000 hertz. Turn up the volume on that. See, I got it on 640 kilohertz deviation. I'm just cranking it up. Here it stops. 1.28 megahertz deviation seems to, maybe that's broken. Maybe I got a fault with this. Or maybe I don't have that if it's an option. But this is working. You see the FM modulation on the spectrum analyzer. Shut that off. Turn on the AM modulation. Turn up the volume on that, and you can see the AM modulation, the effect it has on the carrier. What am I at here? I'm at this AM. I'm at 100% modulation. Turn that off. So I think we're golden. This thing's working. So I'm gonna leave it at that. I still got one more thing I want to do though. All right. So one thing I want to do is fix this pilot lamp, and it just pulls out from the switch. And if you take this part out, it is a replaceable bulb. And you can buy these from HP, I guess. I don't know, maybe you could 30 years ago, but not anymore. This is just a neon lamp. So what I'm going to do is I'm going to try replacing this neon lamp. Let's try this. I think if I heat up, there's a dimple there with solder in it, and there's probably solder on the end here. Let me see. If this scratches, it's solder. Yeah, it's pretty soft. Okay. So let's grab the bulb by the glass without breaking it. Tighten it as much as I dare. See, that's not going to grip. Maybe if I get... How am I going to grip that? Okay, let's try that. You know what I'm going to do first? I'm going to do this. I'm going to take my solder sucker and see if I can get some of that solder out of there. Clean my tip first. Okay, nice clean tip. I don't know if that did it. I can see a hole in there now. Okay. Let's try this. I might just end up breaking the bulb out of there because it's just going to be a pain. Let's just try heating this up. No. Just doesn't want to cooperate. I can see the wire here, and it's loose now. Okay, let's get a little more aggressive. Problem is I got nothing to grip to. There. That was easy. Look at that. Here's a little bulb. Okay. It's going to be hot. Just want to clean that hole out with Okay, I should be able to get that to work. So we need to select a neon lamp. I wonder if this still works. I don't know, I'll have time to test it. Okay, get another one here. Too big? I'm going to use that one. so. Then there's wires. Will it even fit? That's the problem. This one here, it should. There it is. Okay. Let's trim this. A little more. Trim this, and then we can solder this on. Ouch. A little bit of a bubble there. I'm just going to flatten it down with a file. So we want it to fit back in the holder. There. Perfect. Where's our... There we go. Should work. Let's put it in and try it out. All right, so here we go. Let's give it a try. My bulb back in the holder. And this thing, it kind of, it's keyed. There's a little bump here, and then there's a notch in the thing. So don't stick your finger in there, because that's probably 120 volts on that bulb socket. So let's try this out. Ah, look at that. Perfect. It's working. It's nice and bright too. Nice power, illuminated power switch. Awesome. So that's it for this HP 8640B signal generator. Picked it up for a song, and it needed some work. I think it's a really nice piece of gear. If you ever come across one of these, grab them. It's really a pleasure to work on, and they're really built like you don't find. It's built to a military standard. That's what it is built to, and it's just awesome. But like I said, if you get one, grab it, and if the price is right, all the better. But we're going to leave it at that for today. Hopefully I can get some use out of this. I still use my Fluke whenever I have a chance. That Fluke is awesome as well. It's a digital synthesized signal generator, so I just dial in the frequency I want. I don't have to, with the vernier dial, select it, but works great. Anyways, that's it for today. Thanks for watching, and I'll see you on the next one.